Hello everybody. In our previous session we discuss what exactly string is. Okay, so in this session we will just discuss a next term, that is language. What exactly language is. Okay, but before proceeding with this, let us revise the two terms that we have discussed in our previous session. Okay, so in our previous session, see, we discussed what exactly alphabet is. Okay, so let us revise this point. Alphabet is what? It is a finite non-empty set of symbols. Okay, it is denoted by using sigma, Greek letter sigma. Okay, and then in that session there we discuss example, that is this is one example. Alphabet sigma contains how many symbol? Contains two symbol a b. Again another example of alphabet sigma contains 0 1. Okay, so symbol can be anything. We have already discussed this point. Okay, in our previous session. Okay, so in these two example, in first example symbols are character, in second example symbols are number. Okay, so you can define sigma like this as well. Okay, plus minus like this as well. Okay, and it's not the case like every sigma will contain only two symbols. Okay, what is the condition given? Symbols must be finite. Okay, here see in the definition what they have mentioned, symbols must be finite. Okay, so it is a finite non-empty set of symbol. Okay, so see, this point we have already discussed in detail in this in our previous lecture. So if you have not yet gone through our previous lecture, then please do watch that lecture first and then proceed with this one. Okay, then we discuss what exactly string is. Okay, string is a concatenation of finite symbols from the alphabet. Concatenation of finite symbols from alphabet. For example, here see, sigma is given like sigma is equal to a comma b. Okay, so any combination that you can form of a and b can be treated as string which is defined on this sigma. For example, only a can be string which is defined on sigma. AB can be another string that we can define on sigma. AAABB can be another string that we can define on sigma. This can be again another string that we can define on sigma. But if I write like this, A, B and C, okay, whether this is a valid string defined on this sigma? No, because A and B are belong from this sigma, but C is not the member of that sigma. That's why ABC cannot be a valid string that we can define on this sigma. But if your sigma is given like A, B and C, then this can be treated as valid string on this sigma. Okay, so see, this point we have already discussed in much depth with various examples in our previous session. Okay, so as I said earlier, if you have not yet gone through our previous lectures, then please do watch those lectures first. Okay, and then proceed with this one. Okay, now let us discuss the term of this session. Okay, that is language. Okay, so what is language? Language is a set is the set of all strings of terminal symbols derivable from alphabet. Language, I repeat, language is the set of all strings of terminal symbols derivable from alphabet. Okay, now what is meaning of this statement? Okay, so for better understanding, let us discuss this particular definition of language. See, we are quite familiar with this term language. Okay, but whatever meaning of language which is there in our mind, that meaning is not there here in automata. Okay, so let us discuss what is meaning of language in finite automata, in our subject. Okay, it is having slightly different meaning. Okay, now for better understanding of language, let us discuss one example. Okay, now see, language is the set of all strings of terminal symbols derivable from alphabet. Means we have to take one alphabet we have already discussed in our previous session. Okay, so let us define one alphabet with again suppose two symbols a comma b. Whether this is a alphabet? Yes, this is a alphabet. Why? Because this is finite non-empty set of symbol. because that is a definition given of alphabet. So how many symbols are present in this alphabet? Two symbols. What are they? Small a and small b. Okay. Now I just want to discuss what are different strings that we can define on this alphabet, on this particular alphabet. Okay, so what are different strings that we can define on this alphabet? Only a, okay, only b, a b, okay, a b, okay, b a. It can be what? It can be any combination, any combination of the symbols which are present in this sigma. Getting my point? Okay. Now they are this is only a, only b, a b, a b, b a. They are called as what? They are called as individually. Only a is a string that we define on this sigma, or only b, this only b, it is a string that we define on a given sigma. A b, again a string. Individually they are string defined on the sigma. Okay. And what is language now? Language is the set, language is the set of strings that we can define on sigma. Okay. So here L, see, now language usually in finite automata is denoted by using letter, L. Okay. Now see, this is a L, this is a language that we define on this given sigma. Try to understand this point. Okay. What is language? It is a set of string that we can define on given sigma. Okay. Now see whether now I just want to ask you one question, like if I write a string like this, a b c, whether this is a valid string defined on this sigma? No, because c is not member of the sigma, given sigma. Okay, that's why this is not a valid string defined on sigma. Okay, but and though this is not a valid string defined on the sigma abc, this string cannot be added in the language defined on given sigma. Getting my point? So in the what is language? Language is a set of strings that we can define on given alphabet. I think now this point is clear. Okay. For better understanding, let us discuss one more example. Okay. Now suppose sigma. Now our sigma contain this time suppose 0 and 1. Okay. What are the strings that we can define? String. That's why what I am saying, if you are not compatible with the definition of alphabet and string, then please do watch our previous session first. Okay, and then proceed with this one. Okay. So what I said, now let us consider one more example. Okay, suppose sigma is equal to, this time contains suppose three symbols 0, 1 and 2. Okay, so what can be different strings that we can define on this sigma? Only 0, 1, 2, 0, 2, 0, 1. Okay, 1, 1, 0. Okay, or 0, 0, 2. These are all valid string that we can define on sigma. Okay, and if we form a set of such string, then that set is called as what? Language. And this is specifically language defined on define for this sigma. Okay, so language we can define for sigma only, for alphabet only. Okay, again if I write like this, suppose if I take an example of another string, like say suppose 1, 2, 4. Okay, whether this 1, 2, 4 is a string belong from the language defined on this sigma? No. Why? Because given sigma contain first two symbol, but it does not contain what? It does not contain 4 in it. Okay, so this is actually not the valid string that we can define on this given sigma. Getting this point? And though this is not a valid string, this cannot be present in the language defined on given sigma. Okay, I hope you are getting this particular point, what exactly language is. Okay, so in this session we have revised the term alphabet and string, and then we discuss one more term, that is language. Okay, if you find any difficulty in understanding any point, then drop me a message on our WhatsApp group, otherwise you can ask your query on Google Classroom as well. Okay, so that's all for this session. Stay tuned for further updates. Thank you.